Good morning students. Now in this video I am going to explain about the chief characteristics of the normal distribution. So in the normal distribution the curve plays very important role to solve the problems of probability. Okay, so all the problems of probability in normal distribution we will solve with the help of the figure. Okay, with the help of this curve we are going to solve the problem. That's why we have to know the chief characteristics of the normal distribution curve. Okay now, so first point is the graph of the normal distribution y is equals to f of x in the xy plane is known as normal curve. Okay, in xy plane it is called the normal curve. That is the first point. Second point is the curve is bell-shaped curve and symmetrical with respect to mean, that is about the line x is equals to mu. This is the x is equals to mu line. About that line the curve is symmetric. That means it will divide exactly equal parts at x is equals to mu. Okay, right. And the two tails on the right and left side of the mean extends to infinity. So these ends are extends to infinity. It will not touches the x-axis but it will extend to infinity. Okay, the top of the bell is directly above the mean mu. Okay, the mean value, at that mean value you will get the highest value of the peak value you will get. Okay, now the third point is under the normal curve it represents the total population. The total population is nothing but the total quantity of the thing whatever we consider, that will come under this normal curve. Okay, that will discuss in the next chapter. Population sampling distribution is there. In that one we will discuss about the population. Okay, just remember it is as a the area under the normal curve represents the total population. Okay, and we proved that the total area under the normal curve is unity. That is also we can write as a point. Okay, fourth one is mean median mode of the distribution coincide at x is equals to mu as the distribution is symmetrical. So normal curve is unimodal. It is a unimodal distribution we can call. Okay, why? Because mean, mode, median are all equal for this distribution. Because of that we can call this is a unimodal distribution. Okay, now fifth point is x-axis is an asymptote to the curve. So here already we know that this is a x-axis. The curve will not touches the x-axis from the both side. It will not touches the x-axis. Okay, carefully observe the figure. The curve is close to x but it will not touch the x-axis. So we can call that x-axis is the asymptote to the curve. Is it clear? That is the meaning of asymptote. So after the fifth point we have the sixth point. The linear combination of the independent normal variable is also normal variate. That is, the linear combination means, for example, x is a random variable. If I write the variable y is equals to ax plus b, then this y is also called the normal variable. Is it clear? So that is the seventh point is point of inflection of the curve or at x is equals to mu plus or minus sigma. Observe this line x is equals to mu minus sigma and x is equals to mu plus sigma. The curve is going to change its shape. Okay, so it is concave downwards to concave upwards you are getting. So where the curve shape is going to change, that points are called the points of inflections. Okay, so here x is equals to mu plus or minus sigma are called the points of inflection of the normal distribution curve. Okay, now the eighth point is the probability that the normal variate x with the mean mu and the standard deviation sigma lies between x1 and x2 is given by probability of x1 is less than or equals to x is less than or equals to x2, that is equals to 1 by sigma into root 2 pi integral x1 to x2 e power minus 1 by 2 into x minus mu divided by sigma whole square into dx. It depends on the two parameters. The area is always depends on the two parameters mu and sigma. We get these different normal curves for different values of mu and sigma, and if it is impracticable task to plot all such normal curves, instead by putting z is equals to x minus mu divided by sigma, the RHS of equation 1 becomes independent of the two parameters mu and sigma. Hence z is known as the standard variable. Okay, this is also a very important point. So it is always somewhat difficult to evaluate the integration problems. To overcome this, always we will try to convert variables, standard normal variable z, that is by putting x minus mu divided by sigma is equals to z. Come to the ninth point. The area under the normal curve is distributed as follows. See this curve. The area under this normal curve is divided into the parts like this. In between x is equals to mu minus sigma, x is equals to mu plus sigma, it is 68.27. Okay, so the area under this point x is equals to mu minus sigma, x is equals to mu plus sigma, you have to remember it is a 68.27%. And in between mu minus 2 sigma and mu plus 2 sigma, the area is as 95.43%. The area in between mu minus 3 sigma and the mu plus 3 sigma is 99.73. Okay, so these are the some important points about the normal distribution curve you have to remember. Okay, so with this we are closing this video. Thank you.